Alright, number 22, name the roots of the following equations. So we're going to solve them. So the first one, negative 1/5 x squared equals 5. And so to get rid of the fraction, we're going to multiply both sides by the bottom number. And since this is a negative, I'm actually going to multiply by negative 5 because that'll get rid of the fraction in the negative. So when we do that, the negative goes away and the 5 goes away, and so now I'm just left with 1x squared, or just x squared, equals negative 25. And so now I need to get rid of the square, and so the opposite of squaring something is taking the square root. And so that gives me x equals, and so when we have the 25, that would be square root of 5 plus or minus, and so now we have the square root of that negative, because this really just breaks down to 25 times negative 1, and the square root of negative 1 is I. So the roots of this equation are plus or minus 5i. So let's take a look at the second problem. X squared minus 40 equals 9. So we're going to get x squared by itself, and we're going to add 40 to both sides. Now the reason I'm not minusing the 9 and going to try to factor it that way is because there's no x value. We have an x squared but no x. And so when that happens, we can just solve it like a normal equation just by undoing the operations. So now I have x squared equals 49, and so we square root both sides. And so I end up with x equals the square root of 49 is plus or minus 7. Alright, the third one, we have 1/3 x squared equals 12. Like before, we're going to get rid of the fraction by multiplying both sides by 3. And so they cancel out, and I get x squared equals 36. Now square root both sides, and we have x equals plus or minus 6. And the last problem, 20 plus x squared equals negative 16. Need to get the x squared by itself, so we minus 20 from both sides. And so we end up with x squared equals negative 36. Square root. And so like before, since we have that negative, we know that we're going to have the square root of 36 and also the square root of I, so we get plus or minus 6i. So we have our 4 answers. Alright, 23, what information does the discriminant provide? And so in the quadratic formula, we have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And the discriminant is the b squared minus 4ac. It's what's underneath the radical. And so what happens is, if we look at our quadratic formula and I evaluate the discriminant, the b squared minus 4ac, and I get a positive answer, then that means I can actually square root it and keep working, and I'll end up with 2 answers. If I get 0, then the square root of 0 is just 0, and so it doesn't matter if I add 0 or minus 0, it's still going to be the same. So I'm going to end up with 1 answer, or 1 solution. Here, when it was positive, I had 2 solutions. And now if I have a discriminant that's negative, back in algebra we would say no solutions. Well, now in Algebra 2 we say no real solutions, because we know we can have an imaginary solution, but we say no real solution. So on the graph, the 2 solution touches the graph twice. So you might have a parabola that opens up and touches the graph twice. When it's 1 solution, the graph only touches once, and that happens when the vertex is on the x-axis. And then when we have no real solution is when we'll have a parabola that opens up or down, but the vertex is above the x-axis or below the x-axis. So the discriminant doesn't tell us the minimum or the maximum value, it tells us the number of zeros. Alright, for 24, find the solutions. So we have x minus 2 squared equals 36. And so what we want to do here is we want to undo that square. So we're going to square root both sides. And so now we have x minus 2 equals, and remember the square root of 36 is going to give us a positive 6, but also a negative 6. And so now when I add 2 to both sides, I need to make sure I include it with the other 6. And so we end up with x equals 8, and negative 6 plus 2 is negative 4. So whenever you're have a problem with an equal sign and you're solving and you get an answer, take that answer and plug it in and make sure it works. 8 minus 2 is 6. 6 squared is 36. Take the negative 4. Negative 4 minus 2 is negative 6. Negative 6 squared equals 36. Alright, 25. Which number should be added to make a perfect square trinomial for each of the following? And so this is basically the first step when we complete the square. So what we do is we take this middle term and divide by 2. So 12 divided by 2 is 6. And then we take our answer and we square it. So we take the middle term, divide by 2, and square. That's what we're going to add to both sides. So b, the middle term divided by 2, squared. So what's half of 12? 6. 6 squared is 36. Half of 16 is 8. 8 squared is 64. Now, even with the negative, half of negative 20 is negative 10, but when we square a negative times a negative is a positive, it's always going to be adding here. So the negative 10 squared gives us a positive 100. And the last one, half of 28 is 14, and so 14 times 14 gives us 196. So just ask for what we're going to add, so our answer would be what you see here. Alright, 26, find the zeros of each function. So hopefully by now you can look at this and factor it. If you can't, you can always draw the x. 1 times negative 8 is negative 8, and they have to add to 2. So what number is multiplied at negative 8 but add to 2, and that would be positive 4 and negative 2. So now we want to find the zeros, so we make it equal 0. So what would make this 0? Negative 4. And what would make this 0? Positive 2. Alright, so now if we're going to find the zeros in this one, the first thing we want to do is we want to take out the GCF, and you might look at it and say, well, it doesn't have a GCF. if we're going to use this magic x, you always want to make sure that the coefficient is positive. So what we're going to do is we are going to take out a negative 1. So the negative 1 turns into x squared plus 2x minus 8. And so now hopefully you realize that this and this are the same. So if they're the same, they're going to have the same zeros. So x equals negative 4 and 2. Like before, take out the GCF. So you take out a 2, and we get x squared plus 2x minus 8. Once again, that repeats. And so it's going to have the same zeros. So we get x equals a negative 4 and 2. So the point of this question is for you to realize that even though the functions look different, I mean this one's positive, this one's negative, this one's going to be narrower, they can still have the same zeros.